Welcome to a new test and teardown video. This time it's some more DIY equipment. This one here is from Storno, a very big radio systems manufacturer. And I believe this is I would call this audio test system for land mobile radio systems or something like that. It's very, very beautifully made. Of course, they had a huge test system design department, so they could make really, really cool things. And I think we should call this maybe the model number here, TS-G13 for the power supply. I think this is just the power supply. And then we got some numbers down here that is specific for each of the different modules. I got two of these units, and they consist of a little bit different modules. So this one, of course, the power supply. We got a sequential tone encoder. So that will be this selective call where you hear some different beepity beepity beep. And this one can do 4-tone or 5-tone mode, and that will be the 5 different tones, and you set the frequency dippity dippity dip, and then on and off, and then here you go. And there's another one here. I think this is exactly the same number, so that will be exactly the same frequencies. And again, so we've got 3. But this is a different number. So that means we got some different settings. Flat frequency response. And we got some other frequencies. So that is, that will be the Storno. They call this Storno modes, and they call this CCIR modes. And there you have it, a little audio amplifier. It can drive, no, it's not for a speaker, it's just a little audio amplifier, maybe for microphones or for debugging something. We got a lot of, now it can move. Some gain settings in 1 dB steps, and in, this one I need to. Time base, so there's a pulse generator, burst and interval, fast and slow, repeats, normal and hold, and you can have some trigger and the scope or single or repeat. And this is a little pulse starter. So I think this is all the generators. Let's look at the other one I got. So this is the other one, and it looks like this module doesn't really fit. Still the same power supply, still the same time base, audio amplifier. But here we got decoders. So that means we got, those are Storno modes, the same number here. So this one will be able to decode the different frequencies. And I don't understand exactly how this is working, because if this can decode, then so you set some, is this, how do you know? And where's the input? Maybe input here goes, I don't know exactly how this works. Maybe it goes via this input here, I don't know. Maybe we will, and then dual tone encoder. So that means it can make these just like DTMF, but just 1 tone at the time, right? So you enable some of these, and then you can click it on off some tones. Keep beep, 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 beep. This way you can test the radio's decoder for DTMF. And here at the back. So that will be the number for the power supply or for the entire unit. And there's a built-in loudspeaker, and you can turn this on and off. And a Storno number Little power supply, heat sink and all that. Yeah, I think we should definitely try and open and figure out where the audio input outputs to the different modules, where is that located? It was really easy to open, very service friendly, the way this design is made. I kind of like it. And the power supply we can take out here from the back. I'm a little bit worried about the color of this fuse. Why is this all black there? And then it looks like this power panel here connects everything in parallel. 1, 2, 3, 4, 5. And then we got 1, 2, 3, 4, 5 plug-in modules. Is that right? Yes, that is how it is. Let's try and pull them and have a look. So here is how it works. There is a little dot right there. And the idea is, now it's locked, open or open. See, there's a little pin through that screw that locks this piece of plastic in position. So if this works, then I should be able to pull the modules like that. It is, I'm of course not super surprised to see how good this is designed. We got real silk screen texts on the front, and we got a little metal bracket that's bent. See, that's holding all the switches and such. Really, really good thinking here. So I would not say this is just a random DIY thingy, but it is made by a large professional company, but for their own internal use, definitely. We got some really big tantalum capacitors. So this will be the time base unit. So we got some different ICs out, some counters, NAND gates, and some op amps. Yeah, it's going to be interesting to see what's coming out of that scope. We got some different signals here, and they say even here what is going on with the different tone and keying, and some signals on some positive and negative supply. All that is pretty good explained. So that means I can probably plug these in anywhere I want, because the backplane just showed that everything was connected in parallel. So this is how everything is connected together, and signals transport themselves in and out. So I wonder if this module here, the audio amplifier, is probably the input to everything, and the output here is the output from whatever generates audio. That makes sense, because there is no other connectors for input and outputs. So we're now inside the audio amplifier. I wonder what that means. Single layer board, and I find those two holes in the Elma switches. I think they drilled those holes to be able to put in some cleaning to get these up and running again. But why would you do that? I don't understand exactly what's going on here. The thing is, you normally put in cleaning. You can see this tiny little hole. Yeah, here you go. Can you see this little hole? There's down there at the end of my tip. There. Those are the holes you can use to spray in something. So you don't need to drill holes right there and destroy the switch. And of course, all those resistors, they are, as you can see, high precision, except a few of them. And op amp and some transistors. That will be the output driver, maybe for the speaker, right? And here it's a complete different scenario with the connectors. See, The 3 at the bottom, that is power supply entry. And all this at the top, that's probably ground. Only one ground. And if we look here, see, all this is connected together. And this is a ground. So this is some signals. This will be signals in and out of whatever of the other modules. So this is where they're all mounted together. Aha, how cool is that? So that signal goes to that up here, and this is connected to this level. All right, so I'm finally getting in and out of everything. So this one is the dual tone encoder with all the different frequencies like that. And it is made completely passive using inductors and capacitors and oscillators and whatnot. Oh my goodness. Imagine how to tune this by connecting the right wires to the right inductors and figuring out how to get this running accurately. Those film capacitors here, they are super accurate and stable. 1%. Low loss and everything. There's really good capacitors for oscillators like this. You can even tune, I think there's a screw in here where you can tune this part of, but this will move everything. So it's probably not a good idea to do that. Then they put in some glue. But that is one hefty module. This is the sequential tone decoder. And I got 2 of them, and they are exactly the same. At first, I had the idea they could use different pins to do different things, but that is not the case. They are just everything in complete parallel. And I haven't yet figured out what they do other than they will decode for this special sequence. And I guess maybe the LED here goes on if there is a hit on the correct. Do you reset? How do you, fast reset or slow reset? So this has something to do with reset of when this happened, this alarm, right? See, hand drawn with all the comments here. Hand drawn. And if we look a little bit at the circuit boards here, you can see those are thinner and quite small circuit boards, and they fit a little bit. See this hole here? It fits this part. So the idea is normally they will be flipped like this, and this will be inside a little handheld radio. Well, a little and little, that is, back in the old days, handheld radios, they would be quite big, but this would have been inside one of those handheld radios or a land mobile radio station or something like that. Everything here is pretty old tech. And sometimes you can see a date code on those capacitors. I can't really see that. But that will be 1985, 87 technology. This type of design. And again, oops about that. They drilled holes in the LMAS switches. Why would you do that? And you even put in all sorts of plastic parts. But here you can't spray in from the bottom because of the circuit boards is in the way. And everything here is parallel, by the way. And those signals go to this little encoder board. And here you normally have all the diodes And they are probably disabled by those signals or something like that. Maybe here is the signals going in and out. So, and down there, and then you go here. But normally you have your own personal code. And when somebody wants to call you, then they send this sequence of code, of tones, and then your radio starts beeping, and then you know, oops, somebody called me, and only me. So that is how this sequence of tones worked. Sequential tone encoder. So this is the test generator for the 4 or 5 sequenced tones. Beepity beepity bop. And then you can on or off. I don't know exactly where's the start or pulse or anything like that. Maybe you need to use the time base unit to actually start this. That makes a little bit sense. You can hardly move some of these, and it's again the same problem. They drilled some holes here to destroy the switches, or to try and repair them. I will try and put in, oh, see, now I can move this. Maybe I will spray in some contact cleaner. Here, of course, is a little oscillator where you set the different frequencies, and then you activate the different inductors by probably some diodes switching in the different part of the inductors. So audio actually travels through all this, and that's the oscillator. Oh, there's a little field effect transistor here, probably a part of this oscillator, and that will be a little counter, probably, right? Or this is maybe the counting something, right? 1974. So yes, it is that old. I should probably go and look up this SN. What is that? 6404. Let's have a little look at the power supply. I really like this design, and it's very smart and easy. You can just pull this out, and they made the wires long enough so you can still perform service on this unit without poking out the wires. I see only one little thing that I really would have fixed. The colors for the different wires, they should have written them on the power supply here, and they should also have written it on this circuit board right here, because there's no indications. And what happens if I pull out one of these? How can I remember how to put them back again? So that is why I want to document this in this video, so I have it for the future. See, like this. Yellow, black, red, and blue. And then there's a brown one down there. And there you have it with the colors. The top one here is yellow, and then you have black. See, then there's, okay, this one is, that is weird. They skip one and then blue, red. And then where's the brown one? So the brown one goes, that is the loudspeaker. That is the brown wire. And that goes to the switch. And then there is a resistor. So the idea is normally you would have this loudspeaker in or out. But in out, it's not completely out. Then there is this resistor in series. So it's still very, very weak. But it's still there. So that is a little modification somebody made. So I think that is yeah, real smart. I lifted this resistor so it's not touching the metal here anymore. So that is probably causing everything not to work. And the fuse is close to the metal. I think I will desolder it and move it a little bit up, so we got a few more millimeters. And then I will try to assemble this. I mean, look how beautiful this is. Oh, I found one thing that is a little bit homemade. Double-sided sticky tape for the loudspeaker mounting. What do you think about that? That's a little bit how you're doing it. Those big, nice regulators. Yeah, it's a real nice design. I gotta admit that. So the first thing I want to try is the audio amplifier, because that I feel is the first step to get any kind of action going on. And this is mains, and it's using 3.8 watts in idle. And so this is probably not running on 5 volts. And here we got a little bit of 1 kilohertz, 100 millivolts, and this is the input. Okay, and we hear the tone. So that'll be, oh, you can hear. Okay. Okay, you can really make a lot of noise. So I really like with the dB here and all that, but yeah, I want to try and see if I can get this better. Aha, see? The audio amplifier is not using this supply. So the 5 volt supply is probably for all the other stuff. Let's see what happens with a little bit of cleaning. So I cleaned the switches and actually also these. And here's the audio. See? All this annoying clickety clackety. This is only 1 dB per step. You can't really hear a lot. But alright, the amplifier is now good and fine. Something tells me there's a reason why I got this equipment, and maybe it's because it's not working. So let's try and scope this time base unit. It says here there's a scope, and look at that. There's no ground on this signal. And if I put this on the audio output, see, there's a ground. And if I put in some audio on the input, see, I get signal on the scope. So this part here is correctly connected to ground. Well, this one is completely floating like that. And if I touch, see, ooh, this chassis here is affected by that. So that tells me nothing here is correctly grounded inside this unit. Well. So look at that. If I take another unit, this is a tone encoder. Look at that. This is ground. And this is ground. So there's some power supply grounds and some analog signaling grounds. So those are 2 different grounds. They are just cold. Oops, on this one here, they're just cold. Ground and ground. But the fun thing is, this unit here, there is no ground connection to the front to this metal here. And this way, there's no connection to the BNC connector. Not at all. Isn't that funny? So the only way this could have been working is when this module is completely tightened with this one, and then there's maybe a connection to the chassis here, maybe this, but this aluminium here is also anodized. So that means there isn't really a good electrical connection. So there is a design fault. And this module, the other module here, they solved this by even having brass fittings to the front metal, so everything here is correctly made. Oh, somebody wrote their name in this one. Pretty cool, huh? So I added the missing grounds to this module, and what do you know? We get the little pulse, as you can see here on the scope. And I'm now running in a single sequence mode, so I push the button and then I can get a pulse, or we can go into a little loop, and then I can change the timing. See here, I get a longer or shorter pulse. And what about this? What is this doing? I don't know. Fast and slow. I got some different. Oh, look at that. Now we got some more pulses going on here. And this is slower. What is this doing? Diggity dig. Anyway. Definitely we can see we get some pulses. So that is fine. Now it could be cool to try some of the audio generator modules. So I've now figured out how this actually work with the time base. So the time base is actually also the sequencer, and this sequential tone encoder, there is no sequencer or any counter system in this one. It's all done in the time base unit. And the reason I know that is this switch down here is a normal or hold into the different selected tones. See? So that will be 4 individual tones, and that is of course the 5 tones I got in this sequencer. I bet if I select the first one and then, so that is the first one's tones, like that, right? Now we go back to normal, and then we can start the sequence. See? Or I can go into continuous, and then we can. So this is the speed of the individual tones. So it's supposed to be slowest. Maybe this is the repeat. Ah. Doesn't sound like that. It goes like that, right? Yeah, we can definitely make some. Bibbidi bobbidi boo. Ha ha! Of course, it's a lot of fun to see if I can get the encoder to activate the decoder. So by putting those to the same numbers, I would expect this one should do something. And I try to connect the input and the output together. So I think that the output should now go into the receiving parts like that, right? But it's not working, and I tried both of them, and both of them that I tried with got the same sequence or the same frequencies for each number. It's the same as the encoder one, and now we know the encoder is working, so it can only be the 2 decoders that's not working. That is a little bit odd. It's a little bit sad that I don't have any of the decoders working, so that's just bad luck. Well, what I can play with is the 2 encoders, by the way. I put in the other encoder here, so So it's funny to enable them one by one, but what happens if I enable both of them? Yeah, so you can mix everything together. Yeah, you can definitely use this to play music with. I want to try the last funky thing, and that is the dual tone encoder, and see if that one is doing anything fantastic. So let's experiment with taking the camera a little bit closer. So this is the dual tone encoder. I spent the last hour trying to clean all the switches, and they were like really terrible and unstable, but at the moment I think it works pretty good. So you turn on one of the tones, and then you have this activate down here. You can just key it like this, or you can leave it on. So if this is the first tone, let me try and don't need to be that loud, right? Okay, so if this is the A mode, we got different frequencies. Or so another frequency range again for tone 1. And then exactly the same thing happens here, and you can just switch on here. Okay, so you can imagine what happens if I switch on. This is 1 and this is 2, and then I turn this on. Now you can hear 2 tones at the same time. So now it's the same tone. Can you hear the beating? So what you hear is the frequency difference between those two oscillators. Then they modulate and create this low frequency mixed product. And of course also the double frequency, by the way. So that is how it's working so far. Pretty good with all this. I just don't have any of the decoders working. So I'll make this unit a feature-packed unit with everything that is working, and then I will just keep the other one for spare parts. Nothing seems to be working today. Why aren't they working anymore? That is weird. I don't know. What have I done? So that is how it works. So this is only the power supply for the sequencer. That is funny. But now it is not doing any. Maybe there is a little problem with the sequencer as well. Anyway, I think this video is not going to provide any more fantastic new information. So, thank you very much for watching so far. I hope you had a little bit of fun with this old Storno test system. See you soon again. Bye bye.